This is John Black, Super Chemist. Now we've already made the ethylmagnesium bromide. Uh, now I don't know what the yield was, because if I titrate it to see what the yield was, then I'll lose my, it's not like it's a big reaction. I did a small reaction. Uh, so I'm not going to test it, but I will use carbon dioxide as the electrophile and continue this reaction on to do the Grignard reaction. This is just a Grignard reagent, what we made. Okay. First thing I want to go over is do it at your own risk if you copy anything in the video. Number two, big giant mistake, the biggest mistake, was I should have added some diethyl ether to the pot. The reason I didn't was, one, I forgot. I actually did plan on putting in like 10 or 20 milliliters in there, which still wasn't enough. I should at least put 50 to 100 milliliters, at least covered up the metal. That helps as a heat sink. You know what I mean? That absorbs some of the heat. When I'm dripping that stuff down, it's there's nothing to absorb the heat, so a little bit of diethyl ether that's there just boils away, man. Another thing, I would have used a gram condenser. That would have definitely helped hold in the ether, and also use a longer condenser. I would have used 3 times longer condenser than what I used. I would have went slower at first. My plan, remember, I had a plan to drip it in, the first 10% of the ethyl bromide diethyl ether mixture, right, onto the metal. I was only going to put 10% in, and then if it was reacting, heating up, I was going to keep dripping it in. If not, I was going to stop the dripping until I got it to start boiling. If you noticed in the video, I did not do that. I dripped it in for a couple seconds, and then I dumped in a bunch, dripped it a little bit, and dumped in a little bit more, and that was not smart. I should have just kept dripping it in. I should have stuck to the plan. Drip it in, so 10% of the stuff is in there, and then, like I said, wait and see what happens. Keep the pot boiling the whole time. A couple times I let it stop boiling, and the reason why that's bad is because I mean, if you're using argon or nitrogen, or you're going to use an inert atmosphere, then this doesn't matter really. But if you're not doing that, like in the video, I didn't use any inert atmosphere. I just used regular atmosphere. If you don't keep it boiling, you figure oxygen and water from the air. Even if you keep the water out, most of it by having the drying tube, you still have oxygen. Drying tube ain't gonna scrub any oxygen out. Oxygen will ruin your reaction too. If you have it boiling the entire time, that means you have vapors above, diethyl ether vapors above. That's pushing the oxygen away. You know what I mean? It's like a blanket. And when you stop it from boiling, you remove that blanket and let the oxygen come into the reaction. Okay? So I did that a few times. I'd let it stop boiling. I wasn't perfect. I see now, though, how to control everything, better. Because it did take about 2 hours or an hour and a half or something like that to drip that stuff in. So by all that time, I did get the hang of how to control it a little bit. You need ligands. If you don't have ligands, the reaction will not work. And by ligands, I mean the part of the coordination complex that donates the two lone pair electrons. They donate the 2 lone pair electrons to form a dative bond in a coordination complex. The ligand would be the one that's donating. I forget what they call the one that receives. But Without that ligand, it will not work. That means you need diethyl ether, 1,4-dioxane, maybe THF, tetrahydrofuran, something like that, to that effect. Number 8, at the end of the reflux, at the end, well, before you reflux, at the end, I would shake it. And when I say shake it, I mean I shake the whole apparatus, man. I shook that thing up. And boy, it took off. It really took off. Twice I shook it where it took off. So something wasn't reacting or whatever, and I had to push it into place or whatever, you know what I mean? So I suggest when you get done, you shake it, and then let it keep going until it stops boiling. And when it stops boiling and the temperature starts dropping 1 or 2 degrees, get a warm water bath, put it on there, and reflux it for 15 to 30 minutes. I reflux for 30 minutes. Make sure that it's all reacted, you know what I mean? You shake it to make sure all the metals got reacted, and then you reflux it just in general to make sure that everything has reacted. I think I lost at least 10% of the product due to the fact from I had a controlled runaway reaction about 3 times during this experiment. Okay, 3 times I had a runaway, controlled, but still a runaway, where or at least 50% of it was at the very, very top of the condenser trying to leave the apparatus, and 25% would be in the pot still, and 25% would be in between the pot and the condenser, in vapor form. That's a lot of vapor to be trying to get out of your apparatus. 3 times that happened to me. So if this was like a giant, or even 4 or 5 times bigger than what I did, it definitely would have bumped. With my terrible skills with this reaction, because it was the first time I did it, I would have definitely bumped all the ether out of there and had a big vapor cloud of ether in this room. That's why, you don't put any, no pilot lights, no flames. I don't have none of that around this reaction, that's for sure. Especially with this, because your condenser is going to be up high, right? All the gas is going to be squirted out up on top, but diethyl ether is light, so it wants to go down. So basically it's going to shoot up, make a blanket up on top of the ceiling, and that blanket is just going to slowly go down until it hits some kind of ignition source, like a pilot light. But it'll be just like a big blanket coming down, like a big cloud. Anyways, I guess that's all for this reaction. Like I said, I'm trying to make propanoic acid, so I will react this in a grignard reaction coming up here with CO2 being the electrophile. You all have a great day, and always remember, science is great.